Teachers look for the quickest answer to a question that has a history of being on standardized tests, and so often they don't utilize their class time to explore the many ways of approaching a mathematical concept. This type of teaching does not result in full understanding, learning, or retention. Multimodality is an interactive and necessary tutorial that will further math conversation by introducing different ways of looking at and talking about a single math problem. Cross-referencing modalities reinforce different ways of learning: visual, tactile, auditory, writing, etc. The multimodality approach is a very valuable tool for today's student of mathematics and directly relates to both standardized and classroom test preparation. Probability and statistics. If there are 21 people in a room and everyone shakes hands once with everyone else, how many handshakes in all will there be? Typically, students are taught to memorize the following formula in order to solve this problem. Instead of simply memorizing this formula, let's learn how to solve the problem and understand it through multimodality. To start, let's say we only have two people in a room, Rob and Bob. In this case, there is only one handshake possible for two people. Using the language of mathematics, let's describe the event by making a list and by using simple geometry. Modality 1. Making a list. Let RB mean that Rob and Bob shake hands. Notice that RB is the same thing as BR. Do you get it? Modality 2. Geometric representation. Let the line segment connecting R and B represent the handshake between Rob and Bob. Now let's add a third person to the room, John. Modality 1. If we make a list, we have RB, RJ, and JB, 3 handshakes for 3 people. Modality 2. By adding a person, our line becomes a shape, a triangle. The 3 lines joining R, B, and J show the 3 handshakes. Now let's add a third modality. Modality 3. The lineup. Here, Rob, Bob, and John stand in a line. The person at the end, Rob, goes down the line and shakes Bob's hand and John's hand. Then the next person, Bob, goes down the lineup and shakes John's hand. 2 handshakes by Rob and 1 handshake by Bob makes 3 handshakes altogether. Notice that the lineup and list modalities correspond. 2 plus 1 equals 3. Do you get it? Now let's add a fourth person to the room, Don. Modality 1. If we make a list, we have RB, RJ, RD, BJ, BD, JD. 6 handshakes for 4 people. Modality 2. By adding a fourth person, our triangle becomes a square. The 4 sides and 2 diagonals of rectangle RBJD show the 6 handshakes. Modality 3. Here, Rob goes down the line and shakes Bob's hand, John's hand, and Don's hand. Then the next person, Bob, goes down the line and shakes John's hand and Don's hand. Then the next person, John, goes down the line and shakes Don's hand. 3 plus 2 plus 1 equals 6. Notice that the list and lineup correspond. Using the third modality, the lineup, we can generalize. For 3 people, 2 plus 1 equals 3 handshakes. For 4 people, 3 plus 2 plus 1 equals 6 handshakes. Notice how the person at the end won't be shaking his or her own hand. For 5 people in a lineup, 4 plus 3 plus 2 plus 1 equals 10 handshakes. Can you calculate how many handshakes there will be for 6 people? Choose the correct answer. For 6 people in a lineup, 5 plus 4 plus 3 plus 2 plus 1 equals 15 handshakes. For 21 people in a lineup, the first person shakes 20 hands and the next person shakes 19 hands, so the answer is obtained in the same way, equaling 210 handshakes. You can also visualize the lineup in a different way. You can add 20 plus 1, 19 plus 2, 18 plus 3, and so on, making 10 pairs. If there are 21 people and the last person shakes nobody's hand, there are 20 handshakers, creating 10 pairs. These 10 pairs multiplied by the amount of people in the room equals 210. This brings us back to the original formula, where x stands for the amount of people in the room. In this problem, x equals 21. Here we will replace x with the number 21 and subtract 1 because one person in the lineup will shake nobody's hand. This will give us 20, which we will divide by 2 to get the number of pairs of handshakes, which is 10. Then we will multiply by x, which is 21, the number of people in the room, to get the final answer of 210. Now that you understand the three modalities for this problem, you can easily use any of them, along with the formula, to solve it quickly and easily. What if there were 1,200 people in the room? How many handshakes would there be? Choose the correct answer. Coordinates, equations, and graphs. Let's play a number game. I say a number, you double it and add 1. So if I say 1, you say 3. And if I say 2, you say 5. And if I say 3, you say 7. And if I say 4, you say 9, and so on. Do you get it? Modality 1. Coordinates. Coordinates consist of x and y. What is x? Here we let x stand for what I say, and y stand for what you say. If what you say is double what I say plus 1, we would come up with the following coordinates. If I say 1, you'll say 3. If I say 2, you'll say 5. If I say 3, you'll say 7. What if I say 4? Choose the correct coordinates. Modality 2. Equations. What you say equals 2 times what I say plus 1, so y equals 2x plus 1. In algebra, 2x means 2 times x, or in this case, 2 times what I say, because remember, x stands for what I say and y stands for what you say. Do you get it? What we say varies and changes, so we use the term variable. Variables give you the power of many choices. Using the equation y equals 2x plus 1, what is the value of y if x is 5? Or what do you say when I say 5? Choose the correct answer. Modality 3. Graphs. You can use the coordinates we just created to plot points on a graph. Using the x-axis and y-axis, you can take their values and create a line on a graph, showing how every time the number I say increases, so does the number you say.